valencies of some cation. So we know that the cation that contains the positively charged, they are the positive charged particles. So the cations, they are hydrogen ion, that is the monovalent, divalent and trivalent or variable valencies it may have. Now for the monovalent example is hydrogen ion, that is H plus, so it has 1 plus valency. Ammonium ion, that is NH4 plus, so it has only one positive charge, so that will be its valency. Now for the divalent, so it is the Mg2 plus, and here the positive charge is 2 plus, so that will be its valency. And similarly of the barium, it is 2 plus, so it will be its valency. Now for trivalent, the example is aluminum ion, so its symbol is Al3 plus, so the valency will be 3 plus. Now for the variable valencies, so there are some cations such as copper ion, that is cuprous ion, that is Cu plus, and cupric ion, that is Cu2 plus. So here the valency is different, and that will be the number of charge, that is here plus 1 is its valency and here is plus 2. Similarly of mercurous ion and mercuric ion, so it is exist as Hg plus and Hg2 plus, and it will be their valencies. Now similarly in the case of ferrous and ferric ion, so both exist as Fe2 plus and Fe3 plus, and its valency will be 2 plus and 3 plus respectively. Now if we see the valencies of anion, so anion we know it has negative charge. Now here also there are three categories: monovalent, divalent and trivalent. So for the example of monovalent is hydride ion, so its symbol is H minus, so its valency is 1 minus. Now we take the example of nitrite ion, so nitrite, it is NO2 minus, so it has one negative charge, that is its valency. And if we take example of acetate ion, that is CH3COO minus, so its valency is 1 minus. So here are other examples also. Now if we see divalent, so here the sulfate ion, that is SO4 2 minus, so its valency is 2 minus. Now the sulfite ion, that is SO3 2 minus, so the symbol you have to remember. And similarly in the case of carbonate ion, that is CO3 2 minus, so here the valency is 2 minus. Now if we take the case of the phosphate ion, that is trivalent, so its symbol is PO4 3 minus, so its valency is 3 minus. Now if we see that what is an valency of an element, so it is basically a combining power of that element, and it is basically a measurement of it with other atoms when it forms chemical compounds or molecules. So we can define in another way also, that the number of electron lost, gained or shared by an atom of an element to attain stable configuration, it's called its valency. So basically there are three types of valency, that is positive, negative and variable. If we talk about the positive valency, so what is positive valency? So it is formed as a result of loss of one or more electron during a chemical combination. So that is formed by donating one electron, is called monovalent cation. And for example, if sodium atom, it loses one electron, so its valency is plus 1, so it is monovalent cation. Now divalent cation, so if any atom, it loses two electron, for example magnesium atom, so its valency is plus 2. Now we take an example of aluminium atom, so it loses 3 electrons, so its valency is plus 3, so it is trivalent cation. So a trivalent cation, it is formed by donating 3 electrons, and all the metals, they have the positive valency. Now if we talk about the negative valency, so it is formed as a result of gain of one or more electrons during a chemical combination. So for example, if we take an example of chlorine atom, so it gains one electron and it forms Cl minus, so its valency is 1, so it is monovalent anion. Now another example is oxygen atom, it gains 2 electron and its valency is 2, so it is divalent anion. So it is formed by accepting 2 electrons, and basically all the non-metals, they have the negative valencies. Now we see the variable valency. So some elements, as we have seen earlier also, it shows variable valencies, that means they have more than one valencies. So for example, copper, it shows two valencies of +1 and +2. So hence it can form two compounds with oxygen, that is Cu2O and CuO. Now another example is of iron. So it shows two valencies of +2 and +3. So it can form FeCl2 and as well as FeCl3. Now it should be noted that the atoms having variable valencies are named using a suffix "us" in their lower valency and suffix "ik" in their higher valency. So for example, if we take of the copper, it has valency +1, so its name is cuprous. Now its valency is 2, that is +2, so its name will be cupric, and this will be cuprous. So we can see by their name also its valency. Now here are some elements and its electronic configuration and with their valencies. So for the element that is lithium, its configuration is 2 1, and since the number of electron that is present is 1, so its valency is 1. Now if we take example of phosphorus, so in this case, if the atomic number is more, here the number of electron is more than 4. So here what we will do is 8 minus the number of valence electron, that will be its valency is 3. And in the case of chlorine, that is 287, so here the number of electrons is 7, so we will subtract it by its 8, so that comes out to be 1. So this is how the valency of an element can be found out.